I am Radhakrishna, your mathematics teacher. Today we are going to start the 12th class topic, that is circle. First, let us discuss the basic definition of a circle. The locus of a point P which moves on a fixed plane such that its distance from a fixed point is always constant is called a circle. So, this is the shape of the circle. Suppose C is a fixed point, and if a point P moves such that its distance from C is always constant, say R, then the locus of P or the path of P is called a circle. Okay. Now, the fixed point is called center and the constant distance is called radius. So, here C is center and R is the radius. Okay. Now, let us discuss about finding the equation of a circle. The equation of a circle with center C h comma k and with radius R is given by the formula x minus h whole square plus y minus k whole square is equal to R square. If you take center C h comma k, if a point P say x comma y is always at a constant distance R from C, the path of P is a circle. Now, for getting the equation of the circle, you have to use the distance formula. Distance of P from C is R, so Cp is R. What is the formula for the distance between C and P? Square root of x minus h whole square plus y minus k whole square, it is equal to R. Then squaring on both sides, we will get this formula. Now, if you simplify that equation x minus h whole square plus y minus k whole square is equal to R square, you will get the equation in the form of x square plus y square plus 2gx plus 2fy plus c is equal to 0. Let us see. X minus h whole square plus y minus k whole square is equal to R square. Now, if you expand the two squares, this is x square minus 2hx plus h square, and this expansion of y minus k whole square is y square minus 2ky plus k square is equal to R square. Now, if you write the terms in a proper form from higher degree to lower degree, first you should write x square, then y square, next first degree terms minus 2hx minus 2ky plus h square plus k square minus R square. This entire term is constant, is equal to 0. Now, it is in the form of this equation. So, this is the most general equation of a circle. Okay. Now, if you compare this and this, you can get g is equal to minus h and f is equal to minus k. Now, we know that the center of the circle is h comma k. So, what is the center of the circle? Center will be minus g comma minus f. h comma k will be minus g comma minus f. So, that is the formula for the center of this circle. If the equation of a circle is given in the general form, then this is the formula to find the center. Now, if you compare the constant term, c is equal to h square plus k square minus r square. Now, substituting h and k as minus g and minus f, you will get c is equal to g square plus f square minus r square. Then you will get, taking minus r square to left hand side and c to right hand side, you will get r square is equal to g square plus f square minus c. So, r will be equal to square root of g square plus f square minus c. So, this is the formula for radius of the circle. So, when the center of the circle and radius are given, this is the formula to find the equation of the circle, and when the equation of the circle is given in the general form, this is the formula for center and this is the formula for radius. Now, if g square plus f square minus c is negative, we just derived the formula for radius. Radius r is equal to square root of g square plus f square minus c, and center is minus g minus f. Now, if g square plus f square minus c is negative, then this is radius is imaginary. Then the circle is called imaginary circle. It is called a circle, but it is imaginary. It has center, but radius is a non-real number. Okay. Now, if g square plus f square minus c is equal to 0, then the radius of the circle will be 0. Then the circle has center and radius is 0. Then it is called a point circle. The point is considered as a circle, okay, if the equation is in this form. Okay. If g square plus f square minus c is greater than 0, then it is a real circle. Now, in this chapter we are going to deal with only real circles. So, every time this condition will be satisfied. Okay. Now, if you take a general second degree equation in x and y, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, because any curve that we are going to have in the syllabus, let it be pair of lines, circle, parabola, ellipse, hyperbola, all the curves will have the general equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now, if this equation represents a circle, the condition is a is equal to b and h is equal to 0. Just we have derived the equation of a circle in the general form, x square plus y square plus 2gx plus 2fy plus c is equal to 0. The equation of the circle must be in this form. If this is a circle, there will be no xy term, so h will be 0. And also x square coefficient and y square coefficient, they need not be 1, but they must be equal. If a is equal to b, then if you replace b by a, then you can divide both sides by a and get the equation in this form. Okay. So, this is very important to remember that the conditions are a is equal to b, coefficient of x square is equal to coefficient of y square and the coefficient of xy is 0. Okay. Now, we have a standard notation. In this chapter, we get many formulae in some particular expressions. So, instead of writing the long expressions, we denote them by some letters and we use the formulae in terms of those notations. Let us see. This standard equation, in the standard equation of the circle, the expression x square plus y square plus 2gx plus 2fy plus c is denoted by capital S. Next, this expression is denoted by S1. What is this expression? Here if you write x square as x into x, change the second x to x1. Similarly, here write this as y into y, change the second y to y1. Here this is g into x plus x, change the second x to x1. This is x1, x suffix 1. Similarly, here this is f into y plus y1, f into y plus y, change the second y to y1, then you will get this. This expression is denoted by S1. Next, if you change both x's and both y's to x1 and y1, this expression becomes x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. This is denoted by S11. S11. If you change first x to x1, second x to x2, similarly first y to y1, second y to y2, then this expression becomes this. It is denoted by S12. S12. If you change both x's to x2, both y's to y2, then you will get S22. S22. It is x2 square plus y2 square plus 2gx2 plus 2fy2 plus c. Okay. But some teachers teach this expression as t and this one as S1, but that leads to confusion. I am following the notation used by SL coordinate geometry. Okay. So, let us follow this notation in the whole chapter. Okay. Now, another form of a circle, that is diameter form. That means, in the previous formula, when the center and radius are given, we have derived the equation of the circle using distance formula. Now, if two extremities of a diameter of a circle are given as x1 y1 and x2 y2, a x1 y1 and b x2 y2, then how to find the equation of the circle? This is the formula, but how do we get? A and b are extremities of a diameter. Now, if you take any variable point p x comma y on the circumference anywhere, either on this semicircle or on this semicircle, all of you are aware of the property of a circle that the diameter subtends a right angle at any point on the circumference. So, this angle will be pi by 2. You can take p here also, then also this AP and PB will be perpendicular to each other. So, we use slope formula to get the equation of the circle. What is the slope of AP? All of you are aware of slope formula. Slope of AP is y minus y1 upon x minus x1 into slope of BP is y minus y2 upon x minus x2. What will be the value of this product when two lines are perpendicular to each other? What will be the product of the slopes? All of you are aware, it is minus 1. This is true for any position of P on the circle. Now, cross multiplying, we get y minus y1 into y minus y2 is equal to minus of x minus x1 into x minus x2. Now, taking it this side, you will get this formula. This is called diameter form of a circle. So, Earlier we discussed center and radius form, and this is diameter form. Now let us discuss some more forms. Parametric form. Now if the center of a circle is origin and radius is r, you will get the equation of the circle as x square plus y square is equal to r square. This is considered as shortest form of a circle. So this equation is used in proving some particular results. If you prove it for this circle, it will be true for any circle. Okay. Now the coordinates of any point on this circle C, on this circle, can be parametrically expressed as x is equal to r cos theta and y is equal to r sin theta. Let us take P as x comma y. Now if OP subtends an angle theta with the positive x axis, then this adjacent side will be r cos theta, which is x, and this opposite side will be r sin theta, that is y. So we get the formula x is equal to r cos theta and y is equal to r sin theta. So these are called parametric equations of the circle. Which circle? X square plus y square is equal to r square. So its meaning is, for any value of theta, the point P of r cos theta comma r sin theta lies on that circle for any value of theta. That is why theta is called a parameter. And you can also simply express this point as P of theta, that is the usual notation. So with respect to this circle, the point P of theta means P of r cos theta comma r sin theta. Okay. Now similarly, if the center of the circle is h comma k and radius is r, equation of the circle is x minus h whole square plus y minus k whole square is equal to r square. Now you can take x minus h as r cos theta and y minus k as r sin theta, the equation will be satisfied. Then we get x is equal to h plus r cos theta and y is equal to k plus r sin theta. So these two are the parametric equations of this circle. Here remember that theta is parameter here, h, k, r are fixed. Why I am explaining this point is, the parametric equations of a straight line are also same equations are parametric equations of a straight line. What is the difference? In straight line, r is the parameter, h, k and theta are fixed. This r is the parameter. In circle, theta is a parameter. That means the same equations represent a straight line when r is a parameter, remaining are constants, and it represents a circle when theta is a parameter and r is constant. Okay. So the same thing, if the center of the circle is h comma k and radius is r, then the parametric equations of the circle are x is equal to h plus r cos theta, y is equal to k plus r sin theta. Okay. Next, a very important property I am going to discuss. Let a line L is equal to 0 intersect a circle S is equal to 0 at two distinct points like this. This is circle S is equal to 0, this is line L is equal to 0. It intersects the circle at two distinct points. Then the equation of any circle passing through the points of intersection of the circle S and line L will be in the form of S plus lambda L is equal to 0 for any real value of lambda. So, consider this circle, it passes through the two intersection points A and B, then the equation of this circle will be in this form for some value of lambda. Then you can draw many circles passing through the intersection points, but equation of any such circle must be in this form where lambda is a parameter, it is any real number. Okay. But how? Let us prove it. Now, I will take the circle S as x square plus y square plus 2gx plus 2fy plus c is equal to 0, and the line LB Lx plus my plus n is equal to 0. Now, take that equation S plus lambda L is equal to 0. S plus lambda L will be this plus lambda times this. So, I will write second degree terms, first x square plus y square, and this plus lambda into this will be what? If you take x common, you will get 2g plus lambda L into x plus this plus lambda times this will be 2f plus lambda m into y, 2f plus lambda m into y, remaining is what? C plus lambda n plus C plus lambda n is equal to 0. Now, this equation is in the general form of a circle. Okay. So, for any value of lambda, this is a circle, no doubt. Now, my question is, how can you say that it passes through the points A and B, the points of intersection? Very simple to prove. A and B satisfy both the equations. They are the points of intersection of S and L. So, if we substitute A in S plus lambda L, what happens? S will be satisfied because A lies on S, and L will be satisfied, L becomes 0 when you substitute A. So, you will get 0 plus lambda into 0, it will be 0 for any value of lambda. So, definitely A lies on the circle. In the same way, B also lies on the circle. B also satisfies both the equations individually. So, lambda 0 plus lambda into 0 is 0. So, for any value of lambda, this is a circle and it passes through A and B. Okay. This is very important property which we are going to use in many problems of this chapter. Now, let us take another situation. If the line L is equal to 0 touches the circle S is equal to 0 at point A, that means suppose this is the circle, this is the line. The line touches the circle at A. That means we can assume that when A and B coincide in this figure, it becomes this diagram. Now, then the equation of any circle touching the line and the circle at A will be in the form of S plus lambda L is equal to 0. You can draw many circles touching both the circle and the line at A like this. So, all these circles are touching the line as well as the given circle at A. You can draw any bigger circle also. Okay. Now, equation of any such circle will be in the form of S plus lambda L is equal to 0. the proof is again same as this proof. First we proved that S plus lambda L is equal to 0 is a circle for any value of lambda. Now, if we substitute point A, S and L will be individually 0, so it will be satisfied. So, it passes through point A for any value of lambda. And also, when A and B coincide, you can easily visualize the diagram, it becomes this diagram. So, the circle S plus lambda L is equal to 0 touches both the given circle and the given line at A. Okay. Now, I am going to start problems now on the theory discussed so far. First, one basic question: find the equation of the circle passing through the points 1, 2, 2, -1 and 0, 3. How many points are needed to draw a unique circle? It is definitely 3. 3 non-collinear points should be given to draw a unique circle. If only one point is given or only 2 points are given, we can draw infinitely many circles. Now, I will explain this solution in 2 methods, 2 or 3 methods. First, method 1. Let us assume that the equation of the circle is in the general form. Let the equation of the circle be S is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0. In further classes, I am going to write s is equal to 0 only. I do not write the entire equation. That is the purpose of the standard notation. Okay. Now, let us assume that the circle is s is equal to 0. If it passes through the 3 points, these 3 points satisfy this equation. So, let us substitute the points. Substituting the given points, one by one, substitute 1, 2, you will get 1 plus 4 plus 2g plus 4f, 2f into 2, that is 4f plus c is equal to 0, and we can write it as 2g plus 4f plus c is equal to minus 5. Let us take this as equation 1. Now, substitute the second point 2, -1 in this equation. 2 square 4 and -1 whole square 1 plus 2g into 2, that is 4g. Next 2f into -1, that is minus 2f plus c is equal to 0. Now, we can write it as 2g, sorry, we can write it as 4g minus 2f plus c is equal to 4 plus 1 is 5. If it goes that side, it becomes minus 5. Let us denote it by equation 2. Now substitute the third point, 0, 3. First 0 square 0 plus 3 square 9 plus 2gx is 0 plus 2fy will be 2f into 3, 6f plus c is equal to 0. Then we can write it as 6f plus c is equal to minus 9. Denote this by equation 3. Now we can find the values of g, f and c by solving the three equations. Solving 1 and 2. In the third equation we do not have g, so I will first eliminate g from the equations 1 and 2. Then I can solve with this and get f and c. How to eliminate g from these two equations 1 and 2? I have to multiply the first equation by 2 and subtract the second equation. Multiply the first equation by 2, you will get 4g plus 8f plus 2c is equal to minus 10, multiplying both sides by 2. Now write the second equation as it is, 4g minus 2f plus c is equal to minus 5. Now directly subtracting, we get this minus this, 10f plus c is equal to minus 5. And we have another equation in f and c. Write it here, 6f plus c is equal to minus 9. Now again subtracting, we get this minus this, 10 minus 6, 4f is equal to 4. Minus 5 plus 9 is 4. So we will get f is equal to 1. If we substitute f is equal to 1 in any one of the two equations, we will get c is equal to, substitute f is equal to 1 here, 6 plus c is equal to minus 9. So c will be minus 9 minus 6, that will be minus 15. Now substituting f and c in first equation or second equation, we will get g. Let us substitute in the first equation, 2g plus 4f is 4 into 1 4 plus c means minus 15 is equal to minus 5. Then how much is g? This is minus 11. If it goes that side, it becomes plus 11. 11 minus 4, 11 minus 5, it is 6. 2g is equal to 6 means g is equal to 3. So what is our answer? The equation of the circle is x square plus y square plus 2gx, that is 6x, plus 2fy, f is 1, so 2fy will be 2y, plus c, c is minus 15. So this is the answer to the question. This is method 1. Now let us see what is the method 2. In method 2, I am going to find the circumcenter of the triangle formed by these 3 points. Suppose the 3 points are like this: A, B, C. A is 1, 2, B is 2, -1 and C is 0, 3. Now, if you take the center of the circle as some h, k, p h, k, then P will be equidistant from ABC. All of you know that. So, PA is equal to PB is equal to PC. Where P is the center of the circle. Then you can write PA square is equal to PB square is equal to PC square. What is the formula for PA square? H minus 1 whole square plus K minus 2 whole square is equal to PB square. H minus 2 whole square plus K plus 1 whole square is equal to PC square, this square, that is H minus 0 whole square, H square plus K minus 3 whole square. Now, if you take 2 at a time, let us take first 2. If you equate these two, h square plus k square will cancel. What is the remaining here? Minus 2h after expanding the squares, minus 2h plus 1. Here after cancelling k square, what is remaining? Minus 4k plus 4 is equal to, after expansion if you cancel h square and k square, what is remaining? Minus 4h plus 4 and here plus 2k plus 1. Now simplify it, taking minus 4h this side, minus plus 4h minus 2h is 2h minus 4k and 2k, if 2k is brought this side it becomes minus 2k, so you will get minus 6k. Remaining constant is 1 plus 4 will cancel. So, 2h minus 6k is 0 or h minus 3k is 0. This is equation 1. Now, equating next 2. Again, h square plus k square cancels. What is remaining here? Minus 4h plus 4, same as this, plus 2k plus 1 is equal to, here after cancelling h square plus k square, what will be remaining? Minus 6k plus 9. Now simplify, if it goes that side, 4h minus 8k and 9 minus 5 plus 4 is equal to 0, and cancelling 4 you will get h minus 2k plus 1 is equal to 0. This is equation 2. You can find the equations very quickly. Now, solving 1 and 2, we get the coordinates h comma k of the center of the circle. Substitute h is equal to 3k here, then 3k minus 2k is equal to minus 1. We get k is equal to minus 1. And substituting k here, you will get h is equal to h plus 3 is 0, h is equal to minus 3. So, the center of the circumcircle of this triangle or center of the circle passing through the 3 points is given by minus 3 comma minus 1. What else you need? You need radius of the circle. How to find the radius? You can find the distance of P from any one of the 3 vertices. So, radius R is going to be PA. What is PA? Square root of 1 plus 3 whole square, that is 16, plus 2 plus 1 whole square, that is 9. You will get 5. Now, what is the equation of the circle with center minus 3 comma minus 1 and radius 5? You know the formula for equation of circle. When center and radius are given, you can use it. You will get x minus x h whole square means x plus 3 whole square plus y minus k whole square is y plus 1 whole square is equal to r square. R square is 5 square 25. So, this is our answer. If you expand it, you will get the same answer as the previous method, method 1. Okay. Now, I want to explain a nice method and very quick method for finding the equation of circle passing through 3 points. That is method 3. Method 3. In this method, I am going to apply the property which we discussed just before starting the problems. Let the points be denoted by A, B, C. First, I will take points A and B only. This is A, this is B. I will find out the circle with AB as diameter. We have the formula for diameter of this, for the equation of circle in diameter form. What is the equation of the circle with AB as diameter? Equation of the circle with AB as diameter. Is given by the formula x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. So, it is x minus 1 into x minus 2 plus y minus 2 into y plus 1 is equal to 0. Now, I will find equation of the line passing through A and B. What is the method to find the equation of a line passing through 2 given points? Equation of the line AB. What is the equation of the line AB? Y minus y1 2 is equal to slope into x minus 1. What is the slope? This y2 minus y1 minus 3 by 1 minus 3 into x minus 1. You will get 3x plus y minus 5 is equal to 0. Now, any circle passing through A and B will be in the form of s plus lambda L is equal to 0. So, this is S and this is L. So, I will write S plus lambda L is equal to 0, that is x minus 1 into x minus 2 plus y minus 2 into y plus 1 plus lambda into 3x plus y minus 5 is equal to 0. For any value of lambda, it passes through the points A and B. Now, I want the circle passing through C also. So, by substituting coordinates of C in this equation, we can calculate the value of lambda corresponding to the circle passing through ABC. So, substituting C, substituting C, 0 minus 1 minus 1, 0 minus 1 into 0 minus 2, it is 2, plus 3 minus 2 into 3 plus 1, 3 minus 2 is 1, 3 plus 1 is 4, so plus 4 plus lambda into 0 plus 3 minus 5, that is minus 2 lambda is equal to 0. Then what is the value of lambda? Lambda will be 3. Now, substituting lambda is equal to 3 in this equation and then simplifying, we get the same answer as method 1 and method 2. And I recommend this method for objective type problems, but in the subjective type examinations, better you follow either first method or second method. Okay. In objective type problems, this method will work and we can solve it very quickly. Now, let us move on to the next question. Which of the following equations represents a circle? Question looks very simple, but there is a small twist. Here, first equation is ax plus by plus c1 is whole square plus bx plus ay plus c2 whole square is equal to 0. And all of you know that when the sum of two perfect squares is 0, then both the terms are separately 0. So, this must be 0 and this must be 0. If you take ax plus by plus c1 is equal to 0 and bx plus ay plus c2 is equal to 0, both must be true simultaneously. Then each one represents a straight line. So, these two are non-parallel lines, so definitely they will intersect. So, definitely if you draw the two straight lines, if both are true, it is possible only for point of intersection. So, this first equation represents the point only one point, which is intersection point of these two lines. Now, let us take the second. In the second also, we have two perfect squares. If the sum is 0, then each term is 0. And again the lines are non-parallel. So, again you are going to get the point of intersection. So, both this equation and this equation represent one point. Then is the answer both? No, because the equation should satisfy the conditions. Both are representing a point, no doubt, but if you check the conditions that x square coefficient is equal to y square coefficient and xy coefficient is 0, that will be true only in the second case. Here coefficient of x square is a square plus b square, coefficient of y square is a square plus b square, and coefficient of xy will be 0. Here you will get 2abxy, here minus 2abxy, they will cancel. So, since the second equation is satisfying the conditions of a circle, this can be called as a point, circle, but both are points. So, finally, this is a point circle, this is only a point. Okay. So, answer is B. Let us move on to the next question. This is very interesting question. Find the radius of the circle ax plus by plus c whole square plus bx minus ay plus c dash whole square is equal to r square without expanding the equation. By expanding the equation and putting it in the standard form, what is the formula for radius? Root over g square plus f square minus c, but you are not allowed to expand. So, how to tell radius of the circle without expanding the equation? Now, I will explain the geometrical interpretation of the equation of a circle. Now, let us take the circle x square plus y square is equal to r square. What kind of circle it is? It is a circle with origin as center and radius r. So, if you take x axis like this and y axis like this, this is negative x axis, this is negative y axis. Now, if you take any point P x comma y, this x can be understood as distance of P from y axis, and this y is distance of P from x axis. So, x square plus y square is equal to r square, which is square of the radius. Now, if you understand geometrically, if this is Pm, this is Pn, you can understand the equation as Pm square plus Pn square is equal to r square, where Pm and Pn are perpendiculars from P on two perpendicular diameters, need not be x axis and y axis. Okay. So, if you take a general circle, suppose there are two diameters, then if Pm and Pn are perpendiculars, Pm square plus Pn square is equal to r square will be satisfied. Now, these two lines are perpendicular diameters. So, you can take any two lines, any two mutually perpendicular lines as diameters. So, if you take two perpendicular lines, if you replace x and y by two mutually perpendicular lines, then it represents a circle, but the radius is not r. How to get the radius? If you take this equation, this line and this line are perpendicular to each other. So, when you replace x and y in this equation by two mutually perpendicular lines, the equation represents a circle, but radius won't be r. If you want to get the radius, we have to write the equation in this form. In this form means what? Perpendicular distance form. What is the perpendicular distance of x comma y from this line, first line? If this is x comma y, perpendicular distance of p x comma y from the line ax plus by plus c is ax plus by plus c by root over a square plus b square. Similarly, perpendicular distance of p from this line is bx minus ay plus c dash by root a square plus b square. So, in order to put it in the form of Pm square plus Pn square is equal to r square, I will write the equation as ax plus by plus c by root a square plus b square whole square, and similarly here also we need to divide by b square plus a square, root over b square plus a square or root over a square plus b square. So, plus bx minus ay plus c dash by root over a square plus b square So, I wrote the left hand side expression like this. That means, I have divided the entire LHS by a square plus b square. Square root of a square plus b square whole square is a square plus b square. So, I have to divide RHS also by a square plus b square. So, RHS becomes r square by a square plus b square. Now, this is Pm square, this is Pn square. So, this must be radius square. So, what is the radius of the circle? Radius of the circle is going to be square root of this, r under root a square plus b square. So, this is our answer. We got it without expanding the equation. Okay. Now, moving to the next question. Find the equation of the circle having center on the line x minus y plus 3 is equal to 0 and touching these two lines x plus 2y plus 1 is equal to 0 and x plus 2y minus 7 is equal to 0. It is given that the center lies on this line and it touches both this line and this line. What do you observe in the question? These two lines are parallel lines. So, if you take two parallel lines, the given circle touches both the parallel lines. So, it must be like this, and it has its center on this line. So, draw a line through the center, this line is given. Now, how to find the equation of the circle? For finding the equation of the circle, we need center and radius, and you can easily observe that since these two lines are parallel, the perpendicular distance between these two lines will be the diameter of the circle. So, we can easily calculate the radius of the circle, diameter by 2. So, let us do that first. Diameter d is equal to distance between these two parallel lines. What is the formula for distance between two parallel lines? Mod C1 minus C2, that is mod 1 minus of minus 7 by root over 1 square plus 2 square. What will you get? 8 by root 5. This is diameter. So, what is the radius r? Half of it, 4 by root 5. Now, I want the center of the circle. So, what to do? Now, draw a line parallel to these two lines exactly in the midway between these two lines. If you draw a line parallel to these two and lying exactly in the midway between the two lines. Then how to find that equation? Equation of the line in the midway between these two lines will be given by same first degree terms, and constant can be taken as average of these two. Okay. What is the average of 1 and minus 7? 1 plus minus 7 by 2. How much? Minus 6 by 3 is, minus 6 by 2 is minus 3. So, what is the equation of this middle line? X plus 2y minus 3 is equal to 0. Now, solving this equation and this equation, we get the center. So, what is that line? X minus y plus 3 is equal to 0. How to solve? Just directly subtract. Subtracting the equations, x cancels, 2y minus of y, 2y plus y, 3y, this minus 6 is equal to 0, we get y is equal to 2. Substituting y is equal to 2 in this equation, we get x is equal to y plus x plus 1 is 0, so x is equal to minus 1. So, center of the circle is minus 1 comma 2 and radius is 4 by root 5. So, what is the equation of the circle? Our answer is x minus of minus 1 x plus 1 whole square plus y minus 2 whole square is equal to r square, 16 by 5. So, this is the method. Now, let us move on to the next question. Find the equation of the circle passing through the points a comma 0, 0 comma b and a comma b. It looks similar to the first question we solved. 3 points are given, we have to find the equation of the circle. But sometimes those 3 points may form either equilateral triangle or right angle triangle. In that case, no need to calculate the equation of the circle in the normal method. If it is equilateral, suppose, then in equilateral triangle, you know that centroid and circumcenter coincide. So, if you want center of the circle, directly find the centroid. All of you are aware of the centroid formula, x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So, find the centroid, you will get the center of the circle, then you can find the distance from any one vertex and get the radius. If it is right angled, what is the circumcenter of a right angle triangle? It is midpoint of the hypotenuse. And also, suppose ABC is the right angle triangle with right angle at B. Then, if you take circumcircle, AC will be the diameter of the circumcircle. So, using diameter form, you can find the equation of the circle very quickly. Now, observe the given points. Observing the given points, first point is a comma 0, it lies on x axis. Second point 0 comma b. Where is the third point? It is with the coordinates x coordinate a, y coordinate b, means it will be here. So, if you join these two and these two, this angle is pi by 2. So, this triangle is right angle triangle with right angle at A comma B. So, definitely this side will be the diameter of the circumcircle. So, directly taking A comma 0 and 0 comma B as extremities of the diameter, you can write the equation of the circle. What is the circle? X minus A into x minus 0 plus y minus 0 into y minus b is equal to 0. Now, simplify it, you will get x square minus ax, here y square minus by is equal to 0, or x square plus y square minus ax minus by is equal to 0. Okay. So, just have a look at the coordinates and observe whether the points form equilateral angle or right angle triangle. In that case, no need of going for other methods, directly you can find the equation of the circumcircle very quickly. Now, moving to next question. If the points 1 comma 0, 2 comma minus 7, 8 comma 1 and k comma minus 6 are concyclic, find the value of k. We can solve this question again in two methods. One method is, you can find the equation of the circle passing through the first 3 points, and by substituting fourth point you can calculate the value of k. So, what is the equation of circle? Let us see. For finding the equation of circle, I explained 3 methods. So, let us follow the third method. What is the third method? Taking the points as A, B, C, D. What is the circle with AB as diameter? Circle with AB as diameter, it will be x minus 1 into x minus 2 plus y minus 0 into y plus 7 is equal to 0. This is the equation of the circle with AB as diameter, plus lambda into equation of the line AB. What is the equation of the line AB? Let us calculate separately. Y minus y1, y minus 0 is equal to, slope of AB is minus 7 minus 0 by 2 minus 1, that is minus 7, into x minus 1. We get 7x plus y minus 7 is equal to 0. So, this is S plus lambda into 7x plus y minus 7 is equal to 0. For any value of lambda, this circle passes through the points A and B, as we have discussed in the recent question. Now, what do we do? For getting the equation of the circumcircle, equation of the circle passing through ABC, this circle should pass through C. So, substituting C. Substituting C, 8 comma 1, 8 minus 1, 7 into 6 plus 1 into 8 plus lambda into, I am substituting 8 comma 1, 1 minus 0 into, plus lambda into 56, 7 into 8, 56 plus 1 minus 7 is equal to 0. Now, how much is this? 42 plus 8, 50 plus how much is 50? 7 minus 7, 50, 50 lambda is equal to 0. So, we get lambda is equal to minus 1. Now, substituting lambda is equal to minus 1, and we can simultaneously simplify the equation. Let us expand this. X square minus 3x plus 2, and this plus y square plus 7y, and substituting lambda is equal to minus 1, minus 7x minus y plus 7 is equal to 0. Now, let us write the equation properly. X square plus y square minus 10x, next plus 6y, what is the constant term? 2 plus 7, 9, plus 9 is equal to 0. This is the circle passing through the first 3 points A, B, C. It is given that A, B, C, D are concyclic. So, point D must satisfy this equation. Now, substituting point D, k square plus minus 6 whole square, 36, next minus 10k plus 6y is minus 36 plus 9, 36 cancels. Now, we got the equation k square minus 10k plus 9 is equal to 0. What are the roots of this quadratic equation? 9 is 9 into 1, 9 plus 1 is 10. So, it can be easily factorized as k minus 1 into k minus 9. Then k is equal to 1 or 9. Okay. This is the regular method. Now, I am going to explain in a nice way the points A, B, C, D are concyclic. So, let us take A, B, C, D. Okay. Now, you know the property of a cyclic quadrilateral. The sum of the opposite angles is always pi. So, this angle plus this angle is pi, and this angle plus this angle is pi. All of you are aware of this property. So, what I will do is, I will take this angle as alpha, this angle as beta, or better, everything is okay. I will take these two angles as alpha and beta. Now, alpha plus beta is pi. So, beta is equal to pi minus alpha. So, tan beta is equal to tan pi minus alpha is minus tan alpha. Now, how do I calculate tan beta and tan alpha? If you take the points, if you write the points here, 1 comma 0, 2 comma minus 7, 8 comma 1, k comma minus 6. For tan alpha, I will use the formula m1 minus m2 by 1 plus m1 m2, where m1 and m2 are slopes of these two lines. What is m1 slope of this line? Minus 7. Slope of this line, this plus this 8 by 6, this plus y minus y2 minus y1 by x2 minus x1, 1 plus 7, 8 by 6, that is 4 by 3. M2 is equal to 4 by 3. Now, M3 is minus 6 minus 1 minus 7 by k minus 8. Now, M4 slope of this line is minus 6 by k minus 1. Now, when you are applying this formula, all of you are aware of the formula for angle between two lines as tan theta is equal to mod m1 minus m2 by 1 plus m1 m2. But here in this method, you should not take mod. If you take mod, what happens? Both alpha and tan beta will be positive, because that formula will give you only acute angle. The acute angle between two straight lines is given by tan theta is equal to mod m1 minus m2 by 1 plus m1 m2. But here one angle is acute, the other angle is obtuse, definitely. Otherwise, sum cannot be pi. If both are acute, sum cannot be pi. So, you have to take the formula as for tan alpha, if you take m1 minus m2 by 1 plus m1 m2 without mod, you have to follow the same cyclic order. For tan beta, we have to apply m3 minus m4 by 1 plus m3 m4. So, here tan alpha is m1 minus m2 by 1 plus m1 m2, and tan beta, for tan beta, see we have followed this order, m1 then m2, here also the same order continues, m3 and m4. So, we have to take m3 minus m4 by 1 plus m3 m4. Now, substitute m3 minus m4 will be minus 7 by k minus 8 plus 6 by k minus 1 by 1 plus m1 m2 m3 m4, 1 plus this product is 42 by k minus 8 into k minus 1 is equal to minus of m1 minus m2, this minus this, minus 7 minus 4 by 3 by 1 plus m1 m2 is 1 minus 28 by 3. Now take LCM and simplify, you will get the quadratic equation whose roots are 1 and 9. So, you will get the same answer, but I think you can solve it very quickly in this method. Okay. So, remaining calculation part you take care. Okay. Let us move on to next question. The abscissa and ordinates of 2 points A and B are the roots of the quadratic equations ax square plus bx plus c is equal to 0 and px square plus qx plus r is equal to 0, then find the equation of the circle with AB as diameter. What is given? The abscissa and ordinates of the points A and B are the roots of these two equations. So, abscissa are the roots of the first equation and ordinates are the roots of the second equation. Then find the equation of the circle with AB as diameter. Let us take A as x1 comma y1, B as x2 comma y2. Then what is the equation of the circle with AB as diameter? It is a formula directly, x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. It is a formula. But x1, do we need to calculate x1 and x2 by writing the roots of the equation? The roots of the equation are minus b plus r minus root over b square minus 4ac by 2a. It is not possible to substitute here. So, the idea behind the question is not that, finding the roots, not finding the roots. Here x1 and x2 are the roots of the first quadratic equation. y1 and y2 are the roots of the second quadratic equation. So, if the roots of ax square plus bx plus c is equal to 0 are x1 and x2, ax square plus bx plus c can be expressed as a into x minus x1 into x minus x2. It is a very simple concept in quadratic equation. Now, what is this? This product? This product is this divided by a. So, I will write ax square plus bx plus c by a. Now, y1 and y2 are the roots of this equation. So, you can write this equation as p into x minus y1 into x minus y2. But since you want an expression in y, let us change this quadratic equation to y. If y1 and y2 are the roots of this equation, then y1 and y2 are the roots of py square plus qy plus r is equal to 0 also. We did not change the equation, we changed only letter x to letter y. So, still roots will be same. So, this can be expressed as p into y minus y1 into y minus y2. So, what is the second term of this formula? It is this divided by p. So, you will get py square plus qy plus r divided by p is equal to 0. So, this is the equation of the circle. You can now simplify. If you take AP as LCM or multiply both sides by AP, then you will get p into ax square plus bx plus c plus a into py square plus qy plus r is equal to 0. So, this is the equation of circle. If you want, you can write the terms in proper form. First, coefficient of x square is ap x square plus apy square. Next, coefficient of x pbx plus aqy plus pc plus ar is equal to 0. Okay. So, this is the final answer. Okay, tomorrow we are going to discuss a few more problems on today's theory, then we will go to next part of the theory. Okay. Until then, bye bye, have a good day.